Evaluate numerical expressions involving rational numbers and exponents. Before we continue on how to evaluate numerical exponents involving rational numbers and exponents, let's try to practice first our skill when we try to evaluate exponents. Let's deal with example 1. Evaluate. We have here a 2 squared. So when we say 2 squared, remember 2 is your base here, and then the 2 on top is what we call the exponent. The exponent tells you how many times you need to multiply the base by itself. So that means that in our a, 2 squared is 2 times 2 or 4. Let's proceed with b. We have the quantity of negative 2 squared. So, since the negative 2 is enclosed in a parenthesis, that means they're considered as a group. So, your base is negative 2, while your exponent is 2. That means you need to multiply the negative 2 by itself twice. Negative 2 times negative 2, they have the same sign, and the operation is multiplication, so it will turn out to be positive. And 2 times 2 is 4. Now, what happens if the negative 2 is not enclosed in a parenthesis, just like the next given? This means that the negative sign is actually not part of the base of the exponent 2. The base here is just 2. And the exponent, the small number on top, that is still the exponent. So that means this negative here is a negative 1 times the exponential form 2 squared. So we can write it down as negative 1 is again because of the negative sign times 2 squared. So let's try to expand 2 squared. That's 2 times 2. 2 times 2 is 4. And then negative 1 times 4, different signs, always negative. So negative 4. Now how about d to the negative 3 cubed? Since in our d now, the negative 3 is not enclosed in a parenthesis, that means that the negative is separate, is a different one, times the cube of 3. So we are multiplying 3 times. Okay, wait. That means that we are trying to write 3 cube as 3 times 3 times 3. Negative, 3 times 3 is 9. 9 times 3 is 27. So, negative 1 times 27, different signs. The operation is multiplication, so it will turn out to be negative 27. And that is our final answer. And for E, I mean, we have the cube of negative 2. So notice that unlike C and D, there's no parentheses involved given the exponent. But here, since negative 2 is already enclosed, that means that you need to multiply negative 2 by itself thrice. And negative 2 times negative 2, you start from the leftmost, going to the right. Negative 2 times negative 2 is 4. Then you have 4 times negative 2, so negative 8. Okay, so now we need to follow the order of operations if we are already if we're already asked to solve for an expression which involves all the operations, then all the sets of rational numbers that we've encountered, the negative integer, the positive integer, zero, fraction, or decimal. So what do we do now? We follow PEMDAS. So first, perform operations inside parentheses. Second step is to evaluate exponents. So we need to deal with exponents this time. And third, we need to multiply and divide from left to right, regardless whether the first thing to do on the leftmost is division. That's fine. As long as start from left going to the right. And the last one, the last step is add and subtract from left to right. Okay, let's try some examples. Now we are asked to evaluate A. So don't forget to follow PEMDAS. So P for parentheses, E for exponents, M and D is for multiplication and division, but they go together. You'll have to start from left going to the right. And the last one would be add and subtract from left going to the right. So, given this one, you'll start with parentheses. So as you can see, we have something here inside the parentheses that you can simplify. That means you start there. So 24 minus 16 is 8. So I guess that's the last um, parenthesis that we can see, something that we can still combine. The rest is still a parenthesis, but it's only one integer inside, and that's okay. So now, 8 squared, that's the next thing to do, deal with the exponents. We have 8 squared, so that means it's 64. Divide by negative 8 minus 2 times negative 3. Next is to multiply and divide from left to right. That means you start from 64 divided by negative 8 because it's in the leftmost part. So now, 64 divided by 8 is 8. And then, they have different signs. This is positive, this is negative. So, it's negative 8. Now, we're now down to multiplying and dividing from left to right. So, notice that this is negative 8 minus 2 times negative 3. So, you will start here. So, negative 8. You can consider this subtraction as negative sign of the 2, okay? Don't remember, if it is subtraction, you're supposed to change it to addition and then get the opposite of the positive 2, and that would be negative. So, that would be 8, negative 8 plus negative 2 times negative 3. So, we're still down here, multiply and divide from left to right. So, you have negative 2 times negative 3. Negative 2 times negative 3 is 6. And since both are negative, so the answer is positive. Negative 8 plus 6, they have different signs again. So we need to subtract. 8 minus 6 is equal to 2. Then the absolute value of negative 8 is 8. And this is 6. 8 is greater than a 6. So we follow the sign of negative 8, which is negative 2. So take note, the m and the d exist here. When we try to multiply negative 2 by negative 3, and then finally the last step, we added negative 8 plus 6 is negative 2. Let's have b. So we have here negative 3 squared times the cube of negative 2 minus the square of negative 4. So you have to begin by dealing with your parentheses. So here you go. And the next thing that you will notice that whatever's inside is already simplified. So all you need to do now is deal with the exponents first. So 3 squared meaning 3 times 3. And then the cube of negative 2 meaning negative 2 times negative 2 times negative 2. Minus the square of negative 4 is negative 4 times negative 4. So 3 times 3 is 9, but don't forget there is a negative sign here. So negative 9. Next would be negative 2 times negative 2 is positive 4. Then 4 times negative 2 is negative 8. So therefore, this one here becomes negative 8. So we're now done by dealing with the exponents. Next, we will multiply and divide from left to right. So negative 9 times negative 8, we need to multiply that. Negative 9 times negative 8, both are negative, so it becomes positive. 8 times 9 now is 72. So next, you will recognize another multiplication between negative 4 and negative 4 as well here inside. So that means that can be written as 72 minus negative 4 times negative 4 to lessen the confusion. Negative 4 times negative 4, because they have the same sign, so it will turn out to be positive. 4 times 4 is 16. Then we're done with multiply and divide from left to right. So now we will now proceed to add and subtract from left to right. 72 minus 56 is the same as 70 plus the opposite of 16, negative 16. They have different signs. That means 72 minus 16, borrow. This 7 becomes a 6, and that 2 becomes a 12. 12 minus 6 is 6. 6 minus 1 is 5. 56. Sorry. Yes, that's a 56. And then, in terms of the sign, 72 is greater than a negative 16. in terms of absolute, depending on their absolute value. 72 is greater than a 16. That means we follow the sign of the 72, which is positive. So positive 56. Let's proceed to our last example. C. This time, this involves fraction. So it's up to you how will you end your answer as long as you're doing the correct rule. Whether you will convert that fraction to decimal because you're more comfortable dealing with decimals compared to fractions, or you can just take as if you're dealing the same problem in the given situation. So now we have to start performing operations inside parentheses. So inside the parentheses, it's already simplified. Negative 4 ninths, 20, negative 5, and negative 9. Next is to deal with exponents. We don't see an exponent, so we're good here. Next is to multiply and divide from left to right. So since we're using a fraction bar, or the division symbol, we can do it simultaneously. So in the numerator, you have 1 over 7 times negative 4 ninths, negative 49. We can actually rewrite 49 as 7 negative 7 times 7. Okay. So just to make sure that you're not confused about this, I'll erase this for the meantime. And then going back, that would be negative 7 times 7. And then the 20 can be written as 5 times 4. Then bracket all over. This is still multiplication, so it's okay. Negative 9 can be written as negative 3 times 3. And negative 5 is negative 1 times 5. Oops, I noticed that this is not a bracket, but the absolute value bar. So let me just correct that one. And now you will notice that there are common factors in the numerator and denominator when we multiply already the numbers that were given here. Like for example, we have 1 over 7 times the negative 49. But the negative 49 can be written as negative 7 times 7. If you notice, 7 here is in the denominator, 7 here is the numerator. That means we can cancel out that immediately. And that would also be true here. 1/5 times the quantity of 5 times 4, we cancel out 5. Here, 3 will be cancelled out because the operation between the two is just multiplication. So here, the last tail multiplication, so you can cancel out the 5. So now let's try to check what is left. So 1 times 7 is, 1 times negative 7, is negative 7. Plus, what is left here is just 4. And then, you have 1/3 times negative 3 times 3, but the 3 is already cancelled out. So you have negative 3. Plus, this would be 1 times negative 1, negative 1. So now we can go back again to parentheses. This time, it would be the second time around. So this is supposed to be the second. Negative 7 plus 4. They have different signs. Okay. They have different signs. So you need to subtract the absolute value of negative 7 and 4. Absolute value of negative 7 is 7. Then you have 4. Don't forget the sign. It's originally negative 7. Then this one, negative 3 plus negative 1. Since they're in the other part of the fraction bar, so it's okay to do it simultaneously. So negative 3 plus negative 1, they have the same sign. So you need to add and keep the common sign. 3 plus 1 is 4. Then both are negative, so negative 4. And then next, since this is just a bracket, that means that you just have to add negative 7 with 4. And they have different signs. That means that you need to subtract the absolute value of each number, which is 7 and 4. 7 and 4 is 3. And then negative 7 is greater than 4. So this one will be followed, which is negative 3. And now, in the denominator, if you notice, these are what we call the absolute value bar. So when we talk about absolute value, it's actually the distance of a certain number from 0. So that will turn out to be positive 4. Oops, I'm using a colored pen. So positive 4. So this is now our final answer.